For question 1, to find the speed, you'll divide the distance by the time. Now the distance is 5,658 kilometers. Now the time is 8 hours and 12 minutes. I'll need to convert this into either a fraction or a decimal. So that's 8 and 12 over 60, which simplifies to 8 and 1 over 5 as a decimal. That's 8.2. I'll go with a decimal and I get a speed of 690 kilometers per hour. Now, if you're going to use a fraction, make sure that you press the correct button on the calculator in order to get the right answer. For question 2, I've got an arithmetic sequence. The first term is 85. The common difference is minus 6 because I subtract 6. And the formula for the nth term of an arithmetic sequence is the following. So if I substitute the numbers in, I will get 85 plus n minus 1 times minus 6. Let's expand. 85 minus 6n plus 6. This simplifies to 91 minus 6n. For question 3, I'll split this shape into a rectangle and a triangle like this. Now the base of the triangle is 13 minus x. So 13 minus x is this one. The height is 14, which is the whole thing, minus 8, so I get a 6. Hence, the equation will be the following. 14x, this is the area of the rectangle, plus 6 times 13 minus x over 2, that's the formula for the area of the triangle, must be equal to 91.8. I can simplify the 2 with the 6. Hence, 14x plus 39 minus 3x is 91.8. So 11x equals to 52.8. Hence, x comes out to be 4.8, and that's the final answer. For question 4, the ratio of chicken to ducks is 7:2, and the ratio of ducks to pigs is 5:9. Now I'm given that there are 36 pigs, so I'm going to multiply this by 4. That means I'm going to have 20 ducks. Let's copy this on the left. So if I have 20 ducks, it means I have to multiply this one by 10, which will give me 70 chicken, and that's my final answer. For part A of question 5, I'll expand and get 6x squared plus 9x. The second expansion will give me minus 3x squared minus 5x, and if I simplify, I'll get 3x squared plus 4x. In part B, I need to make t the subject of the formula, so I'll take d to the left. P plus d equals 8t, so t is equal p plus d over a, and that's the final answer. For part C, I'll start by adding these powers. So w to the power of 5 plus n over w to the power of 3 is equal w to the power of 10. Then I will subtract those powers. This will give me w to the 5 plus n minus 3 equals w to the power of 10. So now I can equate the powers of w. This will give me 5 plus n minus 3 is equal to 10. So n comes out to be 8. For part A of question 6, I will let the probability of pink be equal to x. Hence, the probability of orange is equal to 3x. Now, if I add all these, I should get 1. So 0.20 plus 0.12 plus 0.08 plus 3x plus x should be 1. On the left, I get 0.4 plus 4x is equal to 1. X comes out to be 0.15. I want the probability it will land on orange, so I want the 3x. This is equal to 0.45. In part B, I will spin the arrow 150 times. I need an estimate for the number of times it lands on blue. This will be 150 times the probability of blue, which is 0.12, and the answer comes out to be 18. For part A of question 7, I'll divide everything by 2, so I'm going to get minus 2 less than or equal to y less than 3, and the integers in this range are minus 2, minus 1, 0, 1, and 2. For part B, I will rearrange the same way I rearrange an equation. So 7t minus 2t gives me 5t on the left, less than or equal to 34 on the right. So t is less than or equal to 34 over 5. That's the final answer. You can write this as a decimal if you want, but these will still give you full marks. In part A of question 8, I'll just subtract 1.4 times 10 to the power of 9 minus 8.2 times 10 to the power of 7. Now you can put this on the calculator and do it, or if you want to do this a bit manually, then I'm going to keep the first one the same, and then for the second one I'm going to remove a factor of 100 from this one and pass it on to the power of 10, so that's minus 0.082 times 10 to the 9. So now the powers of 10 are equal, so I can just subtract 1.4 minus 0.082, which will give me 1.318 times 10 to the power of 9. In part B, I'm given the population of Fiji. Let's label this F is equal to 1 over K times the population of Sweden. Let's put this as an S. So I have F equals 1 over K times S. Now, if I rearrange, K will be equal to Sweden over Fiji. This is 9.9 times 10 to the power of 6 over 9.1 times 10 to the power of 5, and this comes out to be 10.879. If you round this one, you will get 11 to the nearest whole number. In part A, the common factor is 5, a to the power of 4, c to the power of 3, and I'm left with 5 c to the power of 4 d plus 9 a to the power of 5 h. In part B, I will expand the left hand side. That's 4x squared plus 20x plus 25. You can write the same bracket twice on the side and expand. This is equal to 4x squared plus 4x minus 3. Now I can cancel out the 4x squares, so I'll be left with 16x equals minus 28. So x is minus 28 over 16. This simplifies to minus 7 over 4. For question 10, consider the following table. The middle row is the number of tests, that's 5, 1, and 6. The mean for the first 5 tests is 74, and for all 6 is 77. So the sum of the first 5 tests is equal to 5 times 74, which comes out to be 370, while the sum of all 6 is 6 times 77, which comes out to be 462. Hence, the sixth test is equal to 462 minus 370, which comes out to be 92, and that's my final answer. For question 11, part A, note that 16 can be written as 2 to the power of 4, and the square root of 2 is equal to 2 to the power of 1 over 2. So if I use this, I will get 2 to the power of 1 over 2 times 2 to the power of 4 is equal to 2 to the power of x. Now I'm going to add these powers. So 2 to the power of 4 and a half is equal to 2 to the x. So if I equate the powers, x comes out to be 4.5 or 4.5. For part B, I will multiply these two powers, so I get 11 to the power of minus 30 over 11 to the power of 4, and now I will subtract the two powers, so 11 to the power of minus 34. Hence, the value of n is equal to minus 34. In question 12, the arc length I'm asked to find is the following, and this is given by the following formula. So I will substitute the values in: 50 over 360 times 2 pi times 7. This will come out to be 35 pi over 18, and as a decimal, this is 6.1 centimeters to 1 decimal place. For question 13, I'll first expand the two brackets. So 4x bracket 6x squared minus 7x minus 3. And if I further expand this, I will get 24x cubed minus 28x squared minus 12x, and that's the final answer. For question 14, n is equal to 11. So to find q1, I'll start by finding a fourth of 11, which is equal to 2.75. This implies that q1 is equal to the third value. I'm rounding to the next integer, and the third value is equal to 9 goals. Similarly, for q3, I will find 3/4 of 11. This gives me 8.25. Now I'm going to round this to the next integer position. So I'm going to take the 9th observation. This is 16. This is number of goals. So to find the interquartile range, I will subtract q3 minus q1. This is 16 minus 9, which means I have 7 goals. In question 15, I'll start by finding angle A here. This is 30 degrees because angles between tangent and radius are perpendicular. Then I'll find angle B here, and this is 360 minus 238, that's 122. I'll use this one to find angle C, which is half of B, and then finally I'll find the required angle D here, because A, C, D, and 238 add up to 360. So let's write all this down. So angle A, which is equal to QRO, is equal to 90 minus 60, which is equal to 30, because tangent and radius are perpendicular. angle B, which is POR, is equal to 360 minus 238, which is 122 degrees, because angles at a point add up to 360. Then angle C, which is PQR, is equal to 122 divided by 2, which gives me 61 degrees. The reason is that the angle at the center is twice the angle at the circumference. And finally, D, which is the angle OPQ, is equal to 360 minus the other 3, 30, and 238, and 61, and this comes out to be equal to 31. And the reason is that angles in a quadrilateral add up to 360. For question 16, I'll start by writing x equals 0.28, 13, 13, 13, and so on. Now, the first repeating pattern is the 1 and 3 after the 2 8s. Note that this begins at 2 decimal places after the current position, so that's 100x, and here that's another 2 decimal places to the right, that's 10,000x. So let's write this down. 10,000x is 2813.1313 and so on. Now 100x is equal to 28.1313 and so on, and I will subtract those two. So 9,900x is equal to 2,785. So x is 2,785 over 9,900, and this simplifies to 557 over 1980 as required. In question 17, there are two main methods to do this. For the first method, let 2n be the first even number, so the next one is 2n plus 2, and the next one 2n plus 4. So the difference between the largest and the smallest is 2n plus 4 squared minus 2n all squared. Expanding will give me 4n squared plus 16n plus 16 minus 4n squared. The 4n squared cancels out, and I'm left with 16n plus 16. Now I want to show that this is 8 times the middle number, so I'll take out a common factor of 8, which will give me 2n plus 2, which is the middle number, hence proved. Now, alternatively, you can let 2n be the middle number, so the previous one would be 2n minus 2, and the next one 2n plus 2. So again, the largest one, 2n plus 2 squared minus the smallest, 2n minus 2 squared, will give me the following: 4n squared plus 8n plus 4 minus, and then I'm going to have a bracket because of that minus, 4n squared minus 8n plus 4. Let's remove the bracket. 4n squared plus 8n plus 4 minus 4n squared plus 8n minus 4. I can cancel out the 4n squares as well as the 4, so I'll be left with 16n, which is 8 times 2n, and 2n is the middle number, hence proved. In question 18, I have this table and this histogram. Now, I am given the frequency for the first bar and the last one, and then I'm given the heights of the first 4 bars. So know that for the first bar, I'm given both the actual bar and the frequency. So what I'm going to do now is create 2 extra columns, one that we labeled class width and the other one frequency density. The class width is the difference between the upper and lower bound. So the first one is 10, next one 5, 5, 10, and 30. And frequency density is equal to frequency divided by class width. So the first one is 4 and the last one is 1. So if I go to the histogram, then this height must be 4. So let's label it 4. So now I can easily complete the vertical scale. 1, 2, 3, 4 is there. 5, 6, 7, and 8. So now that I have the y-axis, I can complete the last column with the frequency densities. These are the heights of each bar. So the second one is 7, next one 7.8, and the next one 5.6. Now if you rearrange this formula, frequency will be equal to frequency density times class width. So the second one has a frequency of 35, next one 39, and the next one 56. In part B, we need to complete the histogram. What's missing from the histogram is the last bar. The last bar goes from 30 to 60 and has a height of 1. So let's draw this bar. In part C, we need to find an estimate of the probability that the distance traveled by this person was greater than 25 kilometers. Now to find this, my denominator will be the total number of people and the numerator, the number of people greater than 25. So if I go back to the table, I can add the frequency column. This will give me 200. That's my denominator. Now to find the numerator, I need the number of people greater than 25. So basically I want the area of the last one, which is 30, and half the area of this bar. Now the whole area is 56, so half of it, this half will be half of 56. So let's go here. I have 1 over 2 times 56 plus the last bar, which is 30 over 200. This will give me 58 over 200. You can simplify this as 29 over 100. In part I of question 19, I need the number of elements in A union B. A union B is this region here. So let's add these numbers. 12 plus 10 plus 5 plus 6 plus 9 plus 3 will give me 45. Then in the second one, I need the number of elements in A dash intersection B dash. Now A dash intersection B dash means outside B and outside A, so I need these two regions. So the answer would be 4 plus 8, which comes out to be 12. Now you can think of this as N of A union B dash. That's using the Morgan's law. And then for the last one, I need A intersection B union C. Now A intersection B is this region here, and C is this region here. So basically I want everything that is either blue or red or both. So that's 5 plus 6 plus 10 plus 3 plus 4, which gives me 28. For question 20, I'll start by finding upper and lower bounds for each variable. So t is between 9.65 and 9.75. W is between 5.85 and 5.95, and Y is between 2.5 and 3.5. Now I need the upper bound of this expression. Since I have a fraction, I'll need the upper bound of the top over the lower bound of the denominator, and the numerator is a difference, so I'll take the upper bound of the first number minus the lower bound of the second. Denominator again is lower bound, so I will need to use the following numbers: 9.75, 5.85, and 2.5. So let's substitute this. 9.75 minus 5.85 over 2.5. Put this in the calculator and you will get 1.56. For question 21, I'll start by replacing y with this expression. So x equals 2, big fraction here, 5 over 9, 5 over 5a minus 2, plus 5. I'm going to take the denominator and come to the side to simplify it. So if I expand the bracket, I'll get 45 over 5a minus 2 plus 5 over 1. Now multiply the second fraction by 5a minus 2. So I get 45 plus 5 times 5a minus 2 over 5a minus 2. Then let's expand this. 45 plus 25a minus 10. Denominator stays the same, which is equal to 35 plus 25a over 5a minus 2. So let's go back to my x expression. I have 5 over this fraction plus 25a over 5a minus 2. Now you can think of this as 5 divided by 35 plus 25a over 5a minus 2, which I can flip and change to multiplication. So it's 5a minus 2 over 35 plus 25a. Now I can factorize this expression, take out a common factor of 5. So 5 times 5a minus 2 over 5, 7 plus 5a. And I can cancel out these 5s. So I'll be left with x equals to 5a minus 2 over 7 plus 5a. In question 22, I'll need to find the angle between AD and the base. So I'll draw a perpendicular from D on the base, like this, and close this to make a triangle. So this is the angle I am interested in. Now let's call this point here point M. And let's extract this triangle. Note that for this triangle, I don't know any dimensions, so I'll need to find them. Now to find the height of this triangle DM, which is this one here, consider this right angle triangle. And let's extract that triangle to find dm. So using Pythagoras theorem, dm squared is equal to 12 squared minus 5 squared. This is 119. So dm is the square root of 119. So I can transfer this one back to the red triangle. That's the square root of 119. Next, I'll need to find am, which is this one here. Now to do so, I'm gonna need the base of this shape. So let's extract this as well. So am is the diagonal of half of this base. I'll use Pythagoras theorem again. Am squared is equal to 15 squared plus 5 squared, which is 250. So am is the square root of 250. Let's transfer this on the red shape. So finally, to find this angle, I will do tan of A equals opposite over the adjacent. So A is inverse tan of this fraction. And if you put this on the calculator, you will get that A is 34.6 degrees, and this is the final answer. For question 23, I'll need the following two formulae. Now, I am given that the second term is 8.5 and fifth term is 13. So using the blue statement, 8.5 is equal to A plus 2 minus 1 D. So A plus D equals 8.5. Using the red statement, 13 is equal to A plus 5 minus 1 D. So A plus 4D is equal to 13. So let's subtract these two. The A disappears. I've got minus 3D is equal to minus 4.5. So D comes out to be positive 1.5. And if I substitute this D into any of those two equations, I'll go with the first one. I get A equals to 8.5 minus 1.5. So A is 7. Now, using the purple statement, which gives the sum, I can set up the following equation. 292 equals to n over 2. 2 times A, so 2 times 7, plus n minus 1 times D, which is 1.5. Now, I'll multiply both sides by 2 to remove the denominator here. So 584 is equal to n 14, and if I expand, plus 1.5n minus 1.5. Let's simplify this bracket. 584 equals to n times 1.5n plus 12.5. And now let's expand and take everything to the right hand side. 1.5n squared plus 12.5n minus 584 is equal to 0. Now you can use factorization or the quadratic formula or completing the square. I'll go with the quadratic formula. Now A is equal to 1.5, B is 12.5, and C is minus 584. So N equals minus B plus or minus the square root of B squared minus 4AC over 2A. Let's substitute minus 12.5 plus or minus, and I have the square root of 12.5 squared minus 4 times 1.5 times minus 584 all over 2 times 1.5. So n comes out to be 16, or n is minus 24.33. N must be a positive integer, so n is equal to 16. For question 24, part A, I'll start by finding g of 2. This is equal to 7 times 2 minus 6, which is equal to 8. And then I'll use this as an input for function f. So f of 8 is equal to 8 squared minus 10 times 8 plus 7. And this is equal to 247. So that's the answer for part A. For part B, I'll start by completing this square for the function f of x. It's a quadratic. In order to find the inverse, I must complete the square. So start by taking 5 as a common factor. X squared minus 2x plus 7. This is equal to 5x minus 1 squared minus 1 squared, close the square bracket, plus 7, which is equal to 5. And now if I expand, I'll get x minus 1 squared. And now this is minus 1. If I multiply this by 5, I'll get minus 5 plus 7. I will not expand this bracket, that's the whole target. So 5x minus 1 squared minus 5 plus 7 gives me plus 2. So now I will reverse the roles of x and y. So x equals to 5y minus 1 squared plus 2. Note that when I originally had this function, I had a restriction, x was greater or equal to 1. Once I changed the roles of x and y, now I will have y is bigger than or equal to 1. This will be useful at the end of the question. So let's rearrange. X minus 2 equals 5, y minus 1 squared. Let's divide by 5. So x minus 2 over 5 equals y minus 1 squared. I'm going to take the square roots. Plus minus square root of x minus 2 over 5 equals y minus 1. So finally, I'm going to take the 1 to the other side. So 1 positive 1 plus or minus square root of x minus 2 over 5. And now my inverse function is this expression here. But remember, y must be bigger than or equal to 1. So in order to get a y value that is bigger than or equal to 1, I'll have to use the plus here. So the final answer is 1 plus square root of x minus 2 over 5. For question 25, I'll start by splitting the shaded region into two by drawing the line AB. The red region is a segment with an angle of 50 and a radius of 5 from the left circle, and the blue region is a segment of an unknown angle and a radius of 4 from the right circle. I will extract those two parts of the circle on the bottom right. Now to find the area of each segment, I'll find the area of the sector and subtract the area of the triangle. These are the formulae I will use. Now for the red shape, I have all the necessary information to find the area of the segment, but for the blue one, I am missing the angle. So in order to find the angle, I'll use the cosine rule, which is the following, to find A and B for the red shape, and then this corresponds to A and B on the blue one, since these are the same. So let's start by finding the side A and B. So let's substitute the values in. AB squared is equal to 5 squared plus 5 squared minus 2 times 5 times 5 cos of 50. This is equal to 17.86 and so on. A and B is the square root of this number. That's 4.226182617. You can store this in the calculator if you want. So now using the blue triangle, I will get 4.2 dot 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 squared equals to 4 squared plus 4 squared minus 2 times 4 cos of angle P. Now if I rearrange, cos of P will be 4.22 and so on squared minus 4 squared divided by minus 2 times 4 times 4. This comes out to be 0.4418 and so on. So P is the inverse cos of this number, which comes out to be 63.777666166. So now I can find the two segments, the red and the blue, using the required angle and sides and these two formulae. So let's go to the next page. For the red one, I have the following: shaded area is equal to sector area minus triangle area. This is equal to 50 over 360 times pi 5 squared minus 1 over 2 5 times 5 sine of 50. This comes out to be 1.33275228.6. Let's repeat now for the blue shape. So this is equal to 63.77 and so on over 360 times pi 4 squared minus 1 over 2 4 times 4 times sine of 63.77 and so on. This comes out to be 1.72835213.6. So finally, the shaded area is given by the sum of the two numbers. That's 1.33 and so on, plus 1.72 and so on. This comes out to be 3.06 centimeters square, and that's the final answer. For question 26, I'll start by finding the ratio of either OP to PC or AP to PB. I know none of those two. Now let's use an unknown letter to indicate the fraction OP to the whole thing. Now I can use X, remember this is the fraction, and PC is the rest, is 1 minus X. And let's also put Y on AP. So PB is the rest, it's 1 minus Y. So the strategy here is to find two different ways for the same vector. I'll use OP as my vector, and I'll use two different routes. One will be the direct route from O to P, this one, and the other one will be from O to A and then A to P. So let's begin. OP is a fraction of OC, X OC, which is equal to X times the vector OC, and note that OC is equal to OA plus AC, which is 2A plus 3B. I can expand this and get 2xa plus 3xb. Now let's do the alternative route. So OP is equal to OA plus AP. OA, we know this, this is 2a plus AP. Now note that AP is a fraction of AB and the fraction is y. So this is equal to y times AB. That's 2a plus y. And now I can find AB. AB is AO plus OB. So it's minus 2a plus 5b. Let's expand. That's 2a minus 2ya plus 5yb. And if I factorize a in the first two, I get a times 2 minus 2y plus 5yb. Now, because OP has the same starting and end point, the two roots should be equal. So 2x must be equal to 2 minus 2y. Those are the coefficients of a. And 3x must be equal to 5y. So let's take the red. So I'm going to write equate the a's. This will give me 2x equals 2 minus 2y. And then I will also equate the b's. This will give me 3x equals 5y. I should solve this simultaneously. So for the blue one, I will get x on its own, and it's 5y over 3. And then I substitute this into the red one. This will give me 2 times 5y over 3 is equal to 2 minus 2y. 10y over 3 is equal to 2 minus 2y. Multiply both sides by 3. 10y equals to 6 minus 6y. So 16y is equal to 6. Y is equal to 6 over 16, which is equal to 3 over 8. So if I continue here, x is equal 5 over 3 times y, which is 3 over 8. So this will give me 5 over 8. Now to find OP, you can use any of those two expressions with the x or the y you found. I'll go with the top one. So OP is equal 2 times 5 over 8a plus 3 5 over 8b. This will give me 5 over 4a plus 15 over 8b. And this is my final answer.